so the problem is this. Yeah. So I also teach with an overhead projection, and everything's already prepared that's there. But then the problem is that you have a tendency of going too fast, and then students can't take it down. So you still write on the this chalkboard. So you still set up the overlay, and then you do your example problems on the stuff, so that students have a chance to write down the notes. Otherwise, you're talking too fast, and the students will oh man, and then they'll fall asleep because they don't want to take notes or anything, and they won't read up there. They really don't. They won't. They can't. They can't copy fast enough. Because then what happens is you post those slides on the web, and then they'll come up with.
Oh, okay. So they can do it later.
Yeah, that's right. So here's a typical. This is a research lab. Okay, it's one of the ones that's sponsored
by
Ford
motor company
and National Science Foundation. Okay,
oh,
it's
National
essentially
Science Foundation
right.
as well.
Yeah. Oh yeah. And then of course the big thing being citrus.
Yes.
So this. Yeah.
She had a question.
Oh, yeah, go ahead. Oh, you can ask, yeah.
I have a question. You have a question?
You can ask, don't be shy.
Oh,
the choking one.
That's
already
already
answered the question of the choking. So these are rapid prototype machines?
Which one?
These.
Oh. Okay.
These are the smaller ones. There are also bigger ones in research lab. One of these are 3D printers. 3-dimensional printers. So they print prototypes like that.
Oh, it's
okay.
3D printers.
So those sections there, those sections are pieces of a mold. Yeah, for actually my first graduate student that I'm actually, advising. Yeah, he's building a quad rotor flying aircraft, and that's actually the mold. And then they'll do it with composite overlay.
Oh, composite
to build it
overlay.
to use composite. Yeah, but that's the mold, and that was printed on those machines. So these are what's known as 3D printers. So what happens is that they'll design the CAD that's there, design the pieces that are there, and then they send it over here as if it's a printer, right? And then anywhere from 8 to 16 hours, the next day they'll have those things created. Yeah, so it's not just strictly just from drawings anymore. These pieces are actually built, so that they can know what the build is.
Huh?
Oh yeah. Yes.
Do you know about how many students are here?
Oh, let's see. In the whole university. Yeah, shoot, I'm not sure what the student body is, but I think on the mechanical side we have about 2,500.
Oh, that many?
Yeah, we have about 500 students each. We let in about 500 each year, and there's about 4. Well, that's only undergraduates, and then you have graduate students.
Of course. Yeah.
And you have graduate students, so it could be over 3,000 students just in.
But this is
the whole department.
This is very interesting. So the students can really build.
Oh, absolutely.
The actual.
We have to.
This was non-existent. Just I think about 10 years ago, that was non-existent.
Yeah, it's probably non-existent in most universities either.
Still.
Oh yeah, these machines are expensive.
Oh.
Yeah. So and they're functional. Okay. So for instance that plier. Right. See that plier that's there? That's actually a working plier. So these pieces are actually operational.
Oh my!
So they'll make transmissions and they'll test out transmissions before they actually make the part, and they're actually moving. They're moving.
Actually
parts.
moving.
Oh,
absolutely.
So
it's almost like a real one.
Yeah. Oh, absolutely. Yeah. Except they're in more brittle materials.
Yes.
Yeah. There's a lot of. There's been in the last I would say in the last 10 years, there's been a big shift in focus. I mean, not a total shift, but a more addition is more the practical end of it. Okay, so this department has been traditionally known to be very theoretical. So now the it's not really a shift. The addition to the theory is essentially the practicality of it.
A practical end of it is this is the best for the students as a learning process.
Yes, it needs to be an additional. Okay, it needs to be there. Okay,
it needs to be there.
But the niche that this university has, this department, the niche. I mean, there's still a struggle. Okay, it's very hard to put these machines in. You know, space is very expensive. Okay, so these space. There are 2 schools here. There's still the old school, okay, the old school professors, which says no, we're a theory. That's it. If you want to learn these practical things, you go to DeVry. You don't come to this school. Okay, this school is theory is purely for theory.
But it is the old school of the...
That's the old school of thought. Then there are these new school of thought, which are mostly the younger professors. Okay, and they sit there, no. You know, we're tired of hearing, and I actually was even told. Okay, so I did this in one of my classes immediately, the first year that I taught this class. Because I've been told, no, it was told by others, right, outside. They sit there and they go, you know, we worry about interviewing Berkeley students because they graduated and they've never even held a screwdriver as a mechanical engineer. So then in my mechanical design class, the first lab, I tell them what you're required to do is go down to the machine shop, okay, and pick up a screwdriver. And my job is done. But now you can say you held a screwdriver.
But was it not correct in most universities, the graduate students, all the students graduate from the university, most of them, they never even hold any screwdrivers?
At the graduate level, definitely.
Yeah, I mean,
the graduate undergraduate, not all. Not all universities are that way.
Many of
the top. The top 5 universities in engineering for sure.
Yeah.
For sure it's that way. Okay, and and then the other aspect is also self-preservation as a university. Okay, the problem is traditionally this university has always been creating its own competitor. Okay, because most of the students become professors themselves. The pool of research money is about the same. Okay, so the minute they graduate, the next year they're going to write the proposal to the same pool that my advisor wrote. So immediately my advisor have created his own competitors. So the university begins to see that. They see that it's tougher and tougher to get funding, right? Whereas a school, like the other school down south, Stanford, which is more entrepreneurially oriented, is always getting huge amount of money. And that's because they're very money oriented. Here we're very research oriented. But that's sort of changing now. So a lot of these students are being trained with the hands-on stuff. They're actually encouraged. We now have the Haas Business School, okay, which is also pretty much in top rank. Okay. And there's a lot of cooperative programming, especially between engineering and the business school, to again follow sort of the Stanford model, which is to build up this entrepreneurial spirit. Then the hopes of the universities, of course, again, money's going to come in, you know, to fund the research.
So I can say you are quite optimistic then for the future of this.
What, this university?
Yes,
well, this university will be here for a while.
Yeah.
This university is not going to go away. There's absolutely no way. I mean, there are other aspects of the university that's here. For one, the state will never let this, at least this campus, they'll never let this campus die. Okay, it's a huge moneymaker. It's huge. The amount of money, what you stand in here, this is equivalent to Intel being a manufacturing facility. That's what we are here.
No.
Okay, that's what these labs are for. Okay, essentially they're here to make money for the university. I mean, obviously, otherwise, engineering is very expensive.
But eventually, the new way or the new thought of these professors, the younger ones, I think eventually they are going to win, right?
Oh, you mean well, of course, because the older ones will retire. So
most of them, probably.
Yeah. And I think even NSF and all those sciences are all changing. We can walk down to my lab. So most of these now are research labs. These doors that are in here, outside from equipment.
But you have been lecturing for quite a while, right?
Well, I've been lecturing now. This is my 4th year lecturing. Lecturing this year.
Do you plan to pursue for your to become a professor?
No.
If I may ask you why?
No, I will not.
You know why?
Oh yeah, I absolutely know why. Because all my friends that are professor hate it.
Oh, because
on the other hand,
your colleagues,
I love it.
Most of your colleagues, I think, pursue
all my colleagues, all my friends, all of them are professors. And even here they ask. They even ask me.
But you refuse.
No, I will refuse. Yeah.
Because?
Well, here's the reason. The reason is all the professors that are here aren't here to teach. They're here to do research. Okay? Not that I have anything with research. Okay? I also love research. I wouldn't mind doing it. But the problem is they're plagued with the headache of raising the money themselves. They have to write proposals, they have to get the money. If they don't have the money, they have a headache. So what's important is, of course, the graduate students to publish papers. That becomes their main focus. So then teaching becomes secondary. Whereas on the other hand, I love teaching. This is what I like to do. What I want to do is teach. So I just focus on the teaching part. I have no headaches of raising money and so forth. And then, of course, if I can raise money, I'd raise money for my own business anyway. Why raise money for
so
the
you
university?
feel comfortable for what you are now?
Oh, absolutely. Oh, I love it. You bet.
Because you love teaching, right?
Oh, yeah. Well, at least that part of it.